Well, good evening, everyone. This is July 31st. It's Friday night. It's not quite 10 o'clock. I'm just getting set up for a virtual star party. And at this hour, it's early and we're kind of near the end of Comet NeoEyes. So that's where we'll start. Let me minimize this. And I got the scope set up and I managed to capture NeoEyes. And here we have it. Pretty nice. The camera on the C14 is capturing an exposure every 2 seconds. And so here it is, Comet NeoEyes. And if you look carefully, I'll move my cursor up here, you might see a galaxy over here. That is a very far away galaxy. I don't have a whole lot of detail on it, but I know that it's a magnitude 17 galaxy, so it's pretty far away. If you look carefully at NeoEyes, you might see that we have a little bit of a tail coming off here and here, but it is moving away. We've got a little more color in it than you may have seen in basic images, ones that don't show the ion tail, and as well as the regular tail. But the coma looks really, really green here. I'm hoping that you can see that. I had to enter this manually into our Sky formula here, our Sky software that connects to the scope, because the scope, it's not hooked up to the internet to update, and I didn't want to risk an update tonight. But here we have NeoEyes early on this evening, so nice to see that. I may try to take a couple of pictures of this while I'm here. And then we'll come back and we'll do some more stuff tonight. Tonight I want to look at some galaxy groups. We have a gibbous moon out, but because we're using imaging, it's not going to affect us as much as it would if we were using just visual, our eyes with an eyepiece. So we'll see what we can get tonight. And we're going to look for some groups of galaxies. I've got a couple of dark nebula, which we may not see at all, but we'll give it a shot. And then some other stuff in the sky, not your usual stuff, and then some of the usual stuff that we would look for on any particular night. So with that, enjoy NeoEyes for a moment. What I may do is paste an image of what I get if I capture some images of that after this. So with that, I'll be back in a little bit. And thanks for joining us this evening. So here's an image that I was able to get combining 10 30-second images that I took that evening. I paste it right here for your perusal. We do get a little bit of tail on that comet. The stars are aligned okay. They're just moving because the comet's moving. And so I made this image so it was centered on the comet. Not quite as spectacular as some of the images you may have seen, but it's moving away. It's about 10 million miles further in space than it was a week ago. So it's moving at a pretty good clip. Appreciate the last time we were able to get a look at it tonight. So here you go. So here's our observing list for tonight. As you can see, we've got quite a variety. We'll start out with a globular cluster. We've got a couple of planetary nebula in there. So an open cluster, actually a couple of open clusters. We'll try for a couple of dark nebula, and then a bunch of galaxies. And most of the galaxies we're looking at are groups of galaxies. I thought that would be a good theme, is to try to go for some groups of galaxies. It's always cool to see more than one thing in the field at the same time. And galaxies are always cool to look at and contemplate their distances from us and from each other. So take a look at our list. That's what we'll start with tonight. Of course, we had a surprise having NeoEyes pretty available to us right out of the box. So that was a nice start to our evening. And here we go. Okay, so yeah, it's a treat to see NeoEyes tonight. That's a fun thing to see. Didn't know how much longer we're going to have. It's moving farther away, so the fact that we got a little bit of an image of it tonight is pretty cool. All right, so let's start with, go back to kind of where we were going to go when I started all this. And I'll start with a globular cluster called N19 Ophicus. I think I found it. It's kind of right on the meridian. We'll see what the scope wants to do to get there. We'll slew over there. And it's going to slew towards the meridian. Okay. That's good. So it's a pretty busy chart. But you can see over here is Ophiuchus. The 13th is a zodiacal constellation. It's kind of a big hole in the sky between Sagittarius and Libra is this Ophiuchus. Alright, so we're on M19. So I'm going to go back to the camera here and we'll set it up to capture continuously a couple seconds to see if we're centered on it. There it is. Alright, that's pretty good. That's just a couple of seconds. I'll take a little bit longer image here. We'll take a 30-second image of it. We should just do a single capture. And in the meantime, I'll tell you a little bit about N19 Ophicus. It's discovered by Charles Messier on June 5th, 1764, and he added to his catalog of comet-like objects that year. It was resolved into individual stars by William Herschel in 1784, and his son John Herschel described it as a superb cluster resolvable into countless stars. The cluster contains an estimated 1.1 million times the mass of the Sun, and it is around 11.9 billion years old, and is about 28,700 light years away. And it's one of the most oblate known clusters, so it's kind of flattened a little bit. And what you see on the screen now is what you'd see through a modest telescope. I'll say a 6 to 8 inch telescope, wide with a wide field camera, or wide field camera. Well, this is a wide field camera with a wide field lens, so say a 25 to 35 millimeter lens. I can zoom in, and that's what I'll do to try to get a little more detail out of it. So this would be looking through a high power eyepiece, and we can see that it's not quite as dense a core as some globular clusters could be. Kind of got a goofy something or other on the lens here. Anyway, but this is the risks of what we have of capturing pretty quickly what's out there. But that's a globular cluster, of which we have about 150 to 200 of them in our Milky Way galaxy. Nice object to start the evening with. All right. So next we'll go to something different. We're going to try to go to a planetary nebula. So I will come back in a moment. We will pause this. So I paused us, and we ended up doing a meridian flip, which meant the telescope, instead of the telescope keeps spinning around and around, getting the wires twisted, what it'll do is it'll spin around the long way instead of crossing the middle of the sky. And that helps keep wires uncrossed and keeps everything copacetic. And so I took an image of what we call the blue racquetball, and I don't see it, or it's really faint in this image. This could be it over here. So what I'm going to do, this right here, is I'm going to look over in the sky to see what the sky looks like around it. Oh, they call it the Emerald Nebula on this one. So looks like there's a bright star. We've got a couple of stars here, kind of this little pattern here. So we will look over here to see if we see that pattern. And I don't know, doesn't look good. So we'll do is we'll go to a nearby star to see if we are where we are. So I will pause you, and I'll be back in a moment when I figure out what's going on. Okay, so I recalibrated the telescope. I went to the star Altair and centered it in the telescope. Told the telescope, hey, you're at Altair right here. And then I went back over to the blue racquetball NGC 6572, and we found it. It's actually in the center of the screen right here. Let me minimize this. And right here you have the blue snowball, and unfortunately in an image it is nowhere near as interesting as if you saw it through an eyepiece. Through an eyepiece that is very, very, very blue-green, and it's a little blown out here. I actually took a 2-minute image, and you get the sense of a little color here. This kind of stuff looks a little yellower, and it's not tracking fantastic, but okay. This is a very blue object if you were to look through at this with an eyepiece. And unfortunately, that's how planetary nebula are at some point. When you look at it through a short, this is a relatively short exposure. Now we could probably get a better image of this if we took longer exposure and a little more magnified. This might be something we do with the F11 version of the C14 instead of the F1.9. So that's the second stop, or actually third stop on our tour today, is this little planetary nebula. And I told you we're going to go look at some galaxies, so we'll pause this here and we're going to do a little galaxy hunting next. So I'll be back shortly. So we moved over to the other side of the sky in Ursa Major, and we're going for a relatively dim object. I think this was the dimmest object I had on my list tonight, called NGC 3991. It's an irregular galaxy, but it's part of a group of galaxies. And so I think I might have captured something here. But we got a nice little smear, and I believe this is our galaxy. And there's 1, 2, 3 galaxies here. There's a trio of galaxies. Together they're called ARP 313. So they're this is NGC 3991, and then there's 3994 and 3995. So I'm guessing that the higher number ones are these two, and this is our galaxy here. I'm going to try to do this again. Hopefully we'll track a little bit better on the next shot. So stay tuned. We'll take another shot at this to take a look at these galaxies. Kind of cool to see a whole bunch of galaxies all together. So we're back. Wanted to show you what I found here. So here's those 3 galaxies again. And when I check with my Sky software, I'll pull them up. So there's 1, 2, 3. This is the irregular galaxy we were looking for. That's NGC 3991. And then here's 3994 and 3995. Kind of cool to see them all together here. Go back to the picture. In about 20 seconds we'll get a new image. Hopefully we don't get the smear here. But these are all close together. They're I don't have a distance. Okay, so the diameter of this one is about 55,000 light years, and I don't have a distance for them. I'll have to check them out. Oh, I'm sorry. Yeah, they're estimated to be 143 million light years from us, or from the Milky Way. So there's a little leeway there because the Milky Way is fairly large too. But we definitely captured them. Let's see what our new exposure looks like. And here we go. That's the new exposure. That's pretty good. We did capture those galaxies. You can see it's pretty irregular. This one's kind of bright and elliptical, and another one over here. So we captured this this trio. As I started to say before, it's ARP 313, And these ARP galaxies are all galaxies that Halton ARP is his name. Started cataloging multiple galaxies that were in groups together as part of his studies. So this is not something you'd see through a regular telescope. I wanted to see if we could capture it. You would probably need a large scope to see this. This is a magnitude 13.5 object. So this is not something you'd see through a telescope unless it was a large one. But kind of cool to see anyway. But it's the first on our tour tonight of trying to handle some multiple galaxies in one field of view. All right. So let's go on to another cluster. We saw a cluster early on. We saw a globular cluster early on. Here's an open cluster that we're going to go to. It's very pretty, called the butterfly. So that'll be our next step. Because it's fairly bright, we'll do this on the fly. So I'm going to go over here and I'm going to punch in where the butterfly is. It is M6, so it's a Messier object. Charles Messier cataloged it as a non-comet. I'm hoping I don't have to flip over to the other side of the sky. Let's see where we are. I think we're going to be okay. So we will slew over there. We can watch the scope moving. I'm going to slide across here. It's pretty busy if you're looking at it, but when I zoom in, it actually helps me to find out where we're at. Come way down here. We're going to go to M6, an open cluster, the butterfly cluster. In a moment, you'll see why we call it the butterfly cluster. It's in the constellation of Scorpius, which in summer nights is almost due south of us. As the summer goes on, it moves a little further to the west, and hence we're on that red line. This line in the middle here is the meridian. So it separates east over here from west over here to as far as the telescope's concerned. So here we are on that west. Looks like we've stopped. And what I will do is actually label butterfly cluster here. So I will take a quick image to confirm that I'm where I should be. We'll take a 10-second. We'll take 10-second continuous images to see if that's where we're at. Okay, and that's it. Okay. All right, so that's where we're going to be. You can kind of see that there's like a wing here, then a wing over here, a butterfly. I'm going to center this a little better. So I'll go to my telescope tab, and I'll pull this up over here. And oh, I didn't want to do that. Okay. And we're going to move the scope a little that way. Yep, that did center a little bit. I'm going to move a little more. And we're going to get another image like, oh, wrong way, I guess. Okay, we'll try that the other way. We're going to go this way. 1, 2, 3, 4, 5. Okay. This is what I get for doing it on the fly. This one's also going to be smeared. Okay. All right, so let me take a longer image. I'm going to stop this, and we'll take a 60-second image, and I'll be right back when that's developed. So we have our 60-second image up here now. It gives you a little better view of the butterfly. Here's a little butterfly here, a little butterfly here. It's a pretty cluster, way down south in Scorpius. Very pretty. An open cluster. So these stars all form together out of the same material. It's about 1,600 light years from Earth. It lies between us and the galactic center of the Milky Way. And that's wide field, so that's how big it would be in an eyepiece. It's a pretty big field. It's actually a really very good binocular object. So the magnitude of the cluster is about 4.2, so pretty bright. And we think that it's about 100 million years old, so that makes it very young in astronomical terms. Most of the bright visible stars are bright, and they're hot, young blue stars belonging to spectral class B4 to B5, so they are very, very hot blue stars. And it is really good in binoculars. Now, we've taken an image of it here, but this whole size is about what the size of the full moon would look like. So it's a pretty big object in the sky. The butterfly cluster, or M6 in Scorpio. Pretty cool. All right, more to come. So our next object is a group of objects, actually, is NGC 4631, the Whale Galaxy. And there's actually two large galaxies in this group. You see two large ones and two small, like satellite galaxies to the two large ones. And the Whale Galaxy, like it sounds, kind of looks like a whale with its tail pumping down or up, depending what way you're looking. So you can watch me slew over there, going right past the bright star Arcturus, over to a place called Canis Venetaci. Kind of low in the sky. I'm hoping that we can track okay, being that low in the sky. So I will start an image, and I'll take a 2-minute image and one image, and I'll be back with it in a minute. For you, it'll take no time. Okay, and in no time at all, we have the Whale Galaxy. So this is kind of cool. Here it is right here, kind of shaped like a whale, and you can see it as a companion over here. So the Whale Galaxy is NGC 4631. It's a barred spiral in Canis Venetaci, and its slightly distorted wedge shape gives it the appearance of like a herring or a whale. Sometimes it's even called the Herring Galaxy. It's about 30 million light years away with a magnitude of 9.8, so readily visible in about an 8-inch telescope. With the size of this, you can actually see this pretty well. I mean, I'm zooming in, but and I hope you can actually see that there's some dark lane stuff here and some modeling in the whale. That would be probably not as visible through that, unless it's through a bigger scope. So we can see it because we have a nice big scope taking an image of it. And I'm hoping that you might have noticed something over here. This is NGC, 4656, and it has a small companion as well, right over here, almost in front of it, called NGC 4657. They're mag 9.5 and 12.4, and pretty cool that these are all right there. These galaxies are about 31 to 27 million light years away, and these are very similarly about 28 million light years away. So they're probably interacting with each other. But one of our goals tonight was to try to see galaxies interacting galaxies in the same field of view. So here's a couple that are probably interacting. And low in the sky tonight in the west right now at about a little after 11 o'clock. Kind of cool. Kind of cool. All right. Let's see where we're headed next. We're going to head up to a beautiful spiral. I don't think this has any galaxies next door. It just happens to be a beautiful spiral. We'll go off the galaxy path of multiple galaxies to one that's really pretty. So we'll be back in a minute as I slew over to that galaxy. So So we didn't have to move far. We moved to M106. It was just a couple of degrees away. We're just a few seconds away from that exposure getting coming up on our screen. And this is a classic intermediate spiral galaxy in Canis Venatici, and here it is, very visible in the center of your screen right there. You can actually see a spiral arm coming off here and here. It was discovered by Pierre McCain in 1781. It's about 80,000 light years across and 23.5 million light years away. It's the largest member of the Canis II galaxy group, Canis Venatici, and actually there is a possible companion galaxy. I was mistaken, and that's right over here. That's NGC 4220. It's about 12.2 magnitude. Let me just double check with my other software here. And that's about 42 million light years away. So I said one was 23, the other's 42. So they're about 20 million light years apart. So who knows if they're actually interacting or not. They happen to be in the same field of view though. First discovery was made by William Herschel of the Little Galaxy in March of 1788. This is a barred spiral galaxy. So you can see that there's a bar in here. Let me zoom in. Oh, is that pretty? You can actually see a nice little dust cloud in there. You can see the arms coming out. And there's a bar going across there. There's some famous deep sky images of this. This might be one that's worth taking an image of. It looks like a very pretty galaxy. There's a companion out here. And I'm curious what this one is out here. This looks like an edge-on galaxy. There might even be another one right here. But this looks like an edge-on galaxy, so I'm going to use the software to figure out what that looks like, what that is. So we'll zoom in here. And this is one of the fun things you can do when observing, is to find out, look at what you're looking at. And when you zoom in, oh my goodness, there's all kinds of galaxies here. So here is our galaxy and its little neighbor. And there seems to be something here. Let me see if that's what we're looking at. We're kind of looking at it upside down. So we have our galaxy, and then this guy, and then this guy over here. Let's just see what we're looking at. So this guy, and yeah. So this is NGC 4217. And I'm trying to see if I can get any more information on that. So I will look it up real quick here while I'm here. NGC 4217. That's about 60 million light years away. It's an edge-on spiral, so that confirms what we're looking at. That's an edge-on spiral, and I like these edge-ons because you can actually see dark lanes on the edge because you're looking through all that dust and stuff, and then all the light shining out around it really gives it a stark contrast. It makes it a beautiful looking galaxy. It's right next to M106 according to the description in here, but it might also be a companion. 60 million light years away, so 60 million light years away here, 42 here, 28 there, so they're fairly widely spaced, but all together there's a couple more over here as well, and I don't know that we're going to get those. So there's NGC 4232 and 4231, so 1, 2, 3, 4, 5 galaxies, and those little guys over there, those look like they might actually be interacting a bit. Let's find out a little bit more about those. Yeah, So they're those are pretty far away. Those two galaxies are over 330 million light years away. They're very far. These two guys in our map are these two guys here. And it looks like if we took longer exposure, we could probably get some more detail out of them. I'm sure there's a nice Hubble image of those. So 1, 2, 3, 4, 5 galaxies, maybe even 6 in that image. This one being the prettiest. There's M106 again. Really nice image of M106. We're not trying hard to take beautiful pictures. We're just trying to find stuff like we would through a telescope. But certainly this scope could take some beautiful images. We take long images of things like that. That is a gorgeous galaxy. All right, we'll be back with more very shortly. All right, so we've moved on to the next object here. This is still in Canis Venatici, and I was pronouncing it wrong. It's Canis Venatici, not Venatacci. In Latin, it translates from big dogs. So the big dogs is where we're at right now. These are the hunting dogs of Botes the hunter. And we're going to go from M106 is what you see right here now, and we're going to go to M94, fairly close by, but another interesting galaxy. This is not one that has satellites as much as the other ones we've been looking at tonight. But it's interesting in that it has almost two different rings around it. So here we are. This is M109. This is a 2-minute image, and you can see a really bright core here. You can probably see a little shadow of a ring out here as well. I'll kind of zoom in a little bit. This is discovered by Pierre McCain in 1781 and cataloged in Messier's catalog. Some have characterized it as a barred spiral, but it really seems to be more of an oval. So there's some argument as to what it could be. But it has 2 ring structures. It contains both an inner ring with a diameter of about 5,400 light years. That's this one. That's this here. And an outer ring of about 45,000 light years. That's out here. These rings appear to form at resonance locations within the disk of the galaxy. And in 2008, a study was published showing that it had very little or no dark matter present. So the study was analyzed the rotation curves of the galaxy stars and the density of the hydrogen gas, and found that ordinary luminous matter appeared to account for all of the galaxy's mass. The result was unusual and somewhat controversial, as current models do not indicate how a galaxy could form without a dark matter halo, or how a galaxy could lose its dark matter. I'm going to futz with this a little bit and try to zoom in on getting more detail of that ring. Don't know if I'm getting more detail or not. I am getting a little more detail here. Maybe that's a little too much. So, but you can see there's an outer ring and an inner ring of M94. Kind of interesting. Almost like a 2-ringed galaxy. This outer ring doesn't appear to connect to this one, but it does have some resonance with it. Interesting galaxy, also in Canis Venatici. So here, reset it, it'd be worse. All right, so we will move on to the next one. So we're going to go to some more familiar stuff. If you do a little observing, hopefully we're going to find the pair together in our northern sky of M81, M82, 2 very bright galaxies, pretty easy to spot together in a single eyepiece. I will pause us here, and then we'll slew up to the north to find Bode's galaxy and the Cigar galaxy. Okay, we have slewed up to the two galaxies near the Big Dipper called Bode's and the Cigar galaxy. We have a nice image here of these two galaxies, very popular galaxies to look at. This is Bode's. This is the brighter of the two, almost looking like a face-on spiral. And over here is the Cigar galaxy, sometimes called the starburst galaxy. If you look at this in color, you can actually see a lot of hydrogen alpha regions in there where star formation is going on. And it may have been triggered with an interaction between these two galaxies. Just a beautiful pair of galaxies up in our northern sky. The Cigar galaxy is about 12 million light years away in Ursa Major. It's about 5 times more luminous than the whole Milky Way and has a center 100 times more luminous than our galaxy center. And as I said, the starburst activity is thought to have been triggered by an interaction with the M81 or Bode's galaxy. This is the closest starburst galaxy to Earth, and it's a kind of a prototypical example of that type of galaxy. Down to Bode's galaxy, or M81, it's a grand design spiral. I mean, it is the classic spiral galaxy. It's about 12 million light years away as well, diameter of about 90,000 light years. So it's about half the size of the Milky Way. Due to its proximity to us, its large size and active galactic nucleus, which harbors about 1 million solar mass black hole, it's been studied extensively by professional astronomers. Its large size and relatively high brightness also make it a popular target for amateur astronomers. So this was discovered, as you might expect, by Elert Bode on December 31st, December of 1774. And telescopes with an aperture of 8 inches or larger are necessary to distinguish the structures in the galaxy. But we can kind of zoom in. That's what we'll do, like we're using our eyepiece. And we can actually see some structure here. There's an arm out here. There's another arm over here. Pretty cool. We did a pretty quick 2-minute exposure here, but if we were to do a longer one, we would get a lot more galaxy here. If we move up to the starburst, you can actually see some color in here, red areas where the star formation areas are. You can actually see dust lane coming through here. And that's stuff that you could actually see on longer exposures. But through an eyepiece, it would look a lot like this. You would not see the color in them. They're very bright. A wide field eyepiece would capture both of these in them as well. It's a beautiful, beautiful sight, one that I try to look for anytime I go out and view. So we got a nice shot to the north of this. On a night like this, the moon is out, so looking in the north is a little more advantageous. So beautiful sight. Always look forward to seeing this pair of galaxies in the sky. Let me pause there. So we're on our way now to M13, the Hercules cluster. If I zoom in, you can see where we are here in the sky. This is in the western sky. Oh, actually, it looks like it's in the eastern sky. I'm sorry. Hang on. Yes. Western sky. Western sky. I turned my map around. That's why it looked like it was the wrong part of the sky. So M13, because it's so bright, I don't need a long image of it. I'll take a 30-second image of it, so it should be up pretty quickly. This is a showpiece. I always try to show this through an eyepiece because it is absolutely stunning. This is probably the best example I could show you in the northern hemisphere of a globular cluster. It was discovered by Edmund Halley in 1714 and cataloged into NeoEyes catalog as M13. It's about 145 light years in diameter. It's composed of several 100,000 stars, the brightest of which is a red giant variable star V11. That did not come out well. Let me see here. There we go. That's better. And it's about 22,000 light years from Earth. And individual stars were actually first cataloged in here in 1779. In the if you compare to the stars in the neighborhood of the sun, the stars of N13 are more than 100 times denser than the ones near our sun. The if you ever heard of the Arecibo message that was done in 1974, that had coded information about the human race, DNA, atomic numbers, the Earth's position, other information. It was beamed from the Arecibo Observatory, the radio telescope, towards M13 as an experiment in contacting potential extraterrestrial intelligence or civilizations in the cluster. But the cluster will actually move through space during the transit time, so there's some opinions that might differ as to whether that message will ever get there, because over 22,000 years traveling at the speed of light, it's going to be moving. So we may have just shot right past it, across the bow, or maybe behind the ship as it moved across the sky. So, but this is a beautiful thing to look at. It actually looks three-dimensional. If I can zoom in a little bit, you can actually see stars on the outside, stars on the inside. There are very specific things to look for in here. This is not a high-resolution image. You can actually see a little shadow of an area. It looks like a propeller in here, but you can't see it in this image. Looks like there's a little galaxy up here as well. I don't think I've captured that before on an image. Let's see what that is. If I zoom into M13, what is that little galaxy right next door to it? It would appear that that is NGC 6207. Pretty little galaxy right there. So let me see. That is trying to see the magnitude of that galaxy. It's a star. Keep clicking on a star. Okay, there it is. And I don't have a. I can't give you a brightness on it, but we could definitely pick it out in our picture. There it is right there. But stunning to see this through an eyepiece. It really is very sparkly. Keystone cluster, which I'll tell you why it's the Keystone cluster. If you look at Hercules, the constellation of Hercules, and I don't have the constellations outlined here, it's shaped like a keystone. All right, on to the next object. Into Cassiopeia, to a object called NGC 457, or the ET cluster. And before ET was around, it was actually known as the Owl cluster. There's a couple of very bright stars in the center of it. We're just moments away from it. So here it is. You see an eye here, an eye here. There's bodies here. Here's a foot, and here's a foot. Here's an arm that comes out here, and an arm that comes out here. This is very pretty in an eyepiece. These are very brilliant stars. One's kind of reddish, one's kind of whitish. Of our buddy E.T., the extraterrestrial. It's an open cluster, so these stars formed fairly close together. Sits kind of on the lazy side, lazy W side, lazy side of the W of Cassiopeia, the ET cluster. Very pretty. Even catch this in binoculars. This is a nice view of a nice star cluster. So we're on our way to another group of galaxies. This is NGC 7769, and there's actually a trio of galaxies here. I will take a 2-minute image of these. Let's see what our map will show us for where we are. So I told you it was 7769. The two galaxies nearby are 770, 7770, and 7771. So here we are. I hope we're there. I don't see them labeled here. But we'll take a look. I'll be back in a moment with an image after we start to take it. Here we go. Okay, we are seconds away from getting the exposure. So let me pull up the exposure of, there's supposed to be 3 galaxies here. Now, they look pretty faint. This is NGC 7769. It's the brightest and westernmost member of a nice trio. It's got a magnitude 11.7, so it's fairly dim, but it's got a bright halo around it. It's about 200 million light years away. 7771 appears about 5 arc minutes to the east-southeast. It's a little fainter. It's at 12.9 magnitude, and it's about 210 million light years away. And then the smallest is 7770, and the faintest at 14.4. So these look like our 2 galaxies here, and then there's a faint one right here. That's 7770. These are all spirals. Now, that's not bad for an eyepiece view to see those. I'm going to zoom in, and we can see them a little bit better. 3 galaxies all kind of interacting there, all pretty far away, over 200 million light years away. And that would be the last of our galaxy groups tonight. We did a nice job tracking with those, so kind of cool to see those up. These are in Pegasus, pretty high in the sky at this point for us, so it worked out well to grab those. So let me just look at Pegasus here. There we are. There's where we are, kind of the big, I put the, finally got the outlines of the constellations up there. So it's the Great Square of Pegasus, and these happen to sit right inside there. Very nice. Alright, I got one more place to go, possibly 2, but certainly one more to go. We're going to go take a look at the Cat's Eye Nebula. Now, we've been a little disappointed with some of the planetary nebula we looked at before. This is another planetary nebula. This is pretty through an eyepiece. I'm hoping we can actually see some color in this one, and maybe a little form as well. This is the Cat's Eye. Let's see where she's at. That's got to cross the meridian, so I'll probably be back. We'll see which direction the scope wants to go, and I'll be back in a few minutes. Oh, no, we're going to swing across the north. You can see it swinging. When we go to the north, it likes to swing across the meridian, but when we swing to the south, it does not like to swing across the meridian. So here we are heading to the Cat's Eye Nebula. And then we will take a 2-minute image once we get there. And then what I'll do is we'll get back, we'll get the image, and I'll talk to you a little bit more about that image. So here we capture it, and we'll be back. So we're about 4 or 5 seconds away from capturing the Cat's Eye Nebula up in Draco. And here she is. That's a planetary nebula. Discovered by William Herschel in February of 1786. This is it right here. And it would appear much bluer in an eyepiece. Did not get a really good image of it, unfortunately. A little galaxy over there, it looks like. This was a pretty important planetary nebula. It's the first one whose spectrum was investigated by the English astronomer William Huggins. His observations revealed that the spectrum was not continuous, like stars have a continuous spectrum. This was not, and it demonstrated that aside from the few bright emission lines, that it was not continuous, and it demonstrated that planetary nebulae were gaseous and not stellar in nature. So this was something completely new at the time. Structurally, the object has had high-resolution images by the Hubble Space Telescope, revealing knots and jets and bubbles and very complex arcs. And it's all illuminated by the hot central white dwarf. This type of nebula is difficult to measure. Using measurements of angular expansion, we get estimates of about 3,300 light years away. And it's a young planetary nebula, estimated age of about 1,000 to plus or minus 250 years old. So anywhere from 750 to 1,250 years old. A very young planetary nebula. So this through an eyepiece is much bluer, blue-greener, more on the green side, but this picture does not give it justice. So you come back another day, we'll try this with a native F11. I bet we get a lot more detail on there. So getting late. This is possibly our last one for the evening. Hopefully you enjoyed what we did here. We tried to mix it up a little bit by putting some galaxies in there. Thanks for coming tonight, and hope to see you again soon. Okay, we're going to try one more bonus spot. If this works, great. If not, we had a pretty good night. It's almost straight up, and it kind of needs to be. What this is a dark nebula. Barnard cataloged a whole bunch of these, and it could be difficult for us to see with a short exposure. You might need long exposures in order to get this, but we're going to give it a shot. I'm going to take an 8-minute exposure. We've been tracking pretty well. We'll see what we might get here, and if it happens to be a good exposure, I'll describe it to you when we get it done. So we're just at the first few moments of this long exposure, so once it's done, I'll be back and we'll talk more about this dark nebula up near Deneb and above the North American Nebula and Pelican Nebula. So talk to you shortly. Well, here's our image, and even though we did take a long 8-minute image, I do not see the dark nebula. As I look at this, it would appear that what I'm looking for, so if I reference, this should be right over here. Let me see. These stars. Yeah, it's there's supposed to be some dark lanes in here, but I really don't see them. Don't see them. I guess I could play with this. Let's see if I can get a little darker. No, I don't see it. I don't see it. There's some dark stuff here, but that's not what I was looking for. There's something else that's supposed to be over here, almost shaped like a chicken foot, but we don't see it. Oh well, it's worth a shot. So here's an image of what we were going to try to capture. This is LDN 9881. There's actually a couple in here. You can kind of see there's like a chicken foot sort of thing, and at the end of it was a star. And you could tell by what we're looking at that there was a bit of there was a star at the end of that chicken foot, and you can actually see three little stars in a row that kind of tie in a couple brighter stars for what we were looking for. But unfortunately, we were a little too dim to find. I would imagine that with a long exposure and good tracking, we could probably get an image of this, but we were probably a little beyond what we're trying to do with visually with a quick image of this dark nebula. So dark nebula for later on at some point, I guess. Well, thanks for coming tonight. Hope you enjoyed it, and I look forward to seeing you again soon.